Okay, now let's work on our final goal, verifying that the inverse image in this case is the right adjoint to the extension by 0 by describing the natural bijection. In particular, we have the sections of G over U can be identified with this Hom set. Let's first verify this special case. First, we notice that the restriction of G to U will be isomorphic to OU module Hom from OU to the restriction of G to U. This is by exercise 2.3.D, part C. This restriction is same as I inverse of G. So this guy will be isomorphic through this bijection to the OY module Hom from I shrink of OU to G. This is how we get the identification in here. Now let's prove this. Let's first take an element in here. Let phi be an OY module Hom from I shrink of F to G. And we compose phi with the sheafification. And we get the map from the I shrink pre of F to G. And now we take the restriction of this map and those objects to the open subset U. Since F is a sheaf over U, and this is the extension of F by 0. So after restricting this back to U, we get back script F. And this map is what we want here. It is automatically a homomorphism of OU module. On the other hand, if we start a map in here, a OU module Hom, and we apply I shrink functor the morphism sheaves, we will get this. Notice that this guy is equal to I shrink of I inverse of G. It's an inclusion from this guy to G by the part D of this exercise. This is by exercise 2.6.D. So if we precompose this guy with an embedding from here to here, we will get the morphism from I shrink F to G. A morphism in here, an OI module homomorphism. And now we can define this bijection. For a map phi in here, we define tau of phi to be the restriction of phi composed with sheafification. And for a map here, we define delta of psi to be delta composed with I shrink of psi. And now let's check the delta is inverse to tau. By definition, delta composed with tau of phi is equal to delta composed with phi composed with sheafification with the restriction to u. And by definition of delta, this is equal to iota composed with I shriek of this guy. We hope this long formula is equal to phi itself. To check this, we'll be using the method of taking stocks. Recall that two maps are equal if and only if the induced maps between stocks are equal. When taking the stock, there will be two cases. If P is in U, then the iota sub P, the induced stock map of iota, will be equal to the identity at G sub P. This is basically by the part D, the inclusion map we constructed. When Q is in U, the stock of this guy at Q will be G of Q, and the induced map between stocks will be identity. So this part will be the identity. So it will be the same as the second part. But the second part can be further simplified, because this functor will preserve the stock when P is in U. It follows from here, the part B of this exercise. Okay, so what is this? I remove this U because P is already in U, so this will become phi sub P composed with sheafification sub P. But the induced map of sheafification on stocks will be the identity. So this will be phi sub P. They agree on the level of stocks. So they are the same when P is in U. And second, if P is not in U, then our life will be much easier, because the left hand side I sub P will be 0 in this case. How about the right hand side? Phi sub P. Phi sub P is 0 since this guy is 0. The domain of phi sub P will be 0. So both this term and this term are 0. So in any case, this equation holds. Now let's consider tau composed with delta of psi. By definition, delta of psi is equal to iota composed with a shriek of psi. And after applying tau to this, we get the composition of three maps restricted to the open subset U. And we want to show this guy is equal to psi. To this end, we take the stock. Now there's only one case. For any P in U, in this case, we don't need to consider the case when P is outside of U, because we are looking at the OU modules over the open subset U, not over the whole space Y. Now, the stock of this guy at P will be equal to the stock of the composition of three morphisms without the restriction, because P is containing open subset U. If you look at this guy, it has three parts. Iota sub P composed with I shriek of psi sub P composed with the sheafification sub P. But the first and the third term are all identities, since P is in U. So we get the middle term only. But the middle term is equal to psi sub P, because when P is in U, the stock of I shriek of a sheaf will be the stock of the sheaf itself by the part B of this exercise. So we have verified this equality. So now you can draw the conclusion that delta's inverse is tau. So now we have constructed a bijection between these two harms. And now we want to show the naturality of this bijection. To this end, we need two diagrams. The verification of the second diagram is slightly more difficult than the first one. So let's verify the second one. Suppose we take psi from here, and we want to show that after applying these two arrows to psi and applying these two arrows to psi are the same. Let G be a morphism from the restriction of G to U to the restriction of G prime to U. And we name all four arrows in here. The equation we want to verify is this. And the left-hand side will be equal to, so this is a composition on the left, and delta acting this gives us, by definition, iota composed with I shriek of this guy. And right-hand side will be G composed with iota composed with I shriek of psi. To check that they are equal, check this equality at the level of stock. First, if P is not in U, then before iota's P will be 0. Both sides has iota, and both sides will be 0. And second, if P is in U, then at the level of stocks, as I shriek, iota will plus identity. So the essential part of both sides will be G sub P composed with psi sub P. So both sides will be equal to this guy. If two maps are equal at the level of stocks, they will be equal. So we have verified this. The verification of this guy is similar. Level stocks, we only need to check one case. Because here it is OU module over open subset U. So there will be only one case for the commutativity of this diagram. So we will skip this part and complete the proof.